Let's look at an example that sort of typifies how the trigonometric functions get used in applications. So let's say we have a building that casts a shadow that's 17.3 feet long when the sun is 60 degrees above the horizon. How tall is the building? Well, I don't know about you, but this sort of description of the situation is a little bit hard to understand, so let's start by drawing a picture of this situation. So we have a building, maybe something like this, and for some reason we need to know how tall it is, but maybe it's too tall to just break out a ruler, I guess. It's casting a shadow on the ground. This shadow is like this, and that's 17.3 feet. And the sun is 60 degrees above the horizon, so I guess just because of the way shadows work, the sun is going to be right here, and that means that this angle down here is 60 degrees. Okay, we want to know how tall the building is, so the height of the building, I guess that's this blue length right here. So we don't know that yet, so let's call that x. Anything you don't know, you should give a name, because then you can do calculations with it. Okay, I guess because of how buildings usually get built, this angle here is a right angle, and that means we have a right triangle. We have a right triangle where we know one angle, and we know one side, and we want to know another side. And that's exactly the situation that the trigonometric functions were built to deal with. So we sort of already are getting the feeling that we can use the trig functions to find x, but the question in these sorts of situations is always, which trig function should you use? To decide which trig function you should use, look at what you know, which is, or the length that you know, which is the adjacent side. So we know the adjacent side, and we want the side opposite. So we need to choose a trig function that relates the adjacent side and the opposite side. So that's either going to be opposite over adjacent, which would be tangent, or adjacent over opposite, which would be cotangent. As usual, we could use cotangent, but we'd rather use tangent just because it's one of the big three. Secant, cosecant, and cotangent, you really only use those if you have to. Sine, cosine, and tangent are more convenient, usually. All right, so now we have a plan. We're going to use tangent to relate all of these quantities. So in this triangle, or this triangle is telling us that tangent of 60 degrees is the opposite side, which is x, over the adjacent side, which is 17.3 feet. I'm going to keep track of units here. Okay, now we have an equation where there's only one variable. So we can solve the equation for our x. So multiply both sides by 17.3 feet. Left-hand side as well, 17.3 feet. On the right-hand side, those lengths simplify away. And so we get x is 17.3 feet times the tangent of 60 degrees. But 60 degrees, that's one of those common angles. So we know the tangent of 60 degrees, or at least I hope you know the tangent of 60 degrees. It's the square root of 3. So this is 17.3 times the square root of 3 feet. And remember that all of the trig functions, the quantity that they produce has no units. It's just a number. So this square root of 3 is only a number. It doesn't have any units associated with it. And you can see now that that actually makes sense, because on this line here where we first found x, the only unit on the whole line is the feet. but that's what it should be because x is a length. So we ought to get just feet. If there were any unit here in this blue circle, that would mess up the units that we get for our result. So this is sort of a indication that our trig functions really shouldn't produce any units. So everything makes sense. Okay, so this unknown side is the square root of 3 times 17.3. So 17.3 times square root of 3. That turns out to be 29.96 feet. So almost 30 feet. A floor is about 10 feet, so I guess this is a 3-story building. So the important points for any application like this is, first, look for a right triangle, because if you can find a right triangle, then you can use the trig functions. And second, to choose the appropriate trig function, think about which sides you know and which sides you want, and you pick a trig function that relates those sides.